So, okay, why we are studying the FIR system? It has this interesting ability. One, they are always stable. Doesn't matter what order filter you design. Even if it is 10,000 order filter, it's going to be still stable. You don't have to worry about stability. Second thing is the phase is linear. That means all the frequencies are actually, all the frequency signals are delayed by exactly the same amount. They're going to feel the same way, right? So that means we can approximate any filter we want. The disadvantage is that it needs huge number of coefficients to get a better response. In comparison to this, we will be discussing the second type of filter is actually infinite impulse response filters, which are actually feedback systems. They, on the other hand, have this advantage that with just 2 or third order, they give a response equivalent to 100 order of FIR. So that means less computation. But then they have this disadvantage of getting unstable as well at some point. We're going to be discussing that in the next class anyway, right? And they also have this issue of nonlinear phase. That is the problem with the IIR filter. So FIR filter has its advantages and it has its disadvantages as well, which is the computational cost. Okay, so this is how usually an FIR look like. I mean, it has a finite number of impulses, and after that it becomes 0. Okay, we did discuss this, that all the obvious advantages of digital filter for the FIR filter can guarantee linear phase characteristic, right? It doesn't need, you know, the IR filter can be approximated from any analog filter, but the FIR doesn't need that. And they are like many commercially available software packages that cannot work without FIR systems. So they mostly use the FIR filters for signal reconstruction, signal regeneration.